Hello and welcome to an additional tutorial on the traffic lights demo by Trinity ICT and the Primary Tech Club. What we wanted to do with this particular one is to go into the software coding slightly more and show you how you can write this code in some slightly different ways. And that will give you a better understanding of code in general and then how you can build code in the future. It also shows you some things that might make the coding more efficient in the future as you get to more complicated programs. So the first thing that I want to show you is this part of the code here, which is setup. Now, this particular piece of code, if you can see these curly brackets here, and this statement at the top which says void setup, this actually defines something called a function. And functions are exactly what they are. It carries out a particular activity. So this function, setup, sets the three different pins that we're using as output pins. So this runs when the Arduino PC or the Arduino microcontroller starts running. The first thing it does is it sets these three integer values, red, amber, green, and then it runs a function called setup. It then runs another function called loop. Now, loop itself actually has a special definition within the Arduino system that when it gets to the end of all the instructions within that function, it starts again. So therefore it's a loop. What we want to do now is we're going to create some specific functions and replace some of the code that's inside our loop. So the first function that we're going to create is going to be something that is going to be called turn red on. So there's the code for turn red on. So again, the void at the front here, what this means is that this function does not return any value or any information back to the main computer program. So it just carries out a task, and then when it's finished its task, you go on to the next step. So turn red on, the function is digital write red high. So we know what that is, and that's that line there within this loop. So now that turns it on high. So we can delete that, and now whenever we want to turn the red on, we just use this piece of code here. So we'll put this code in here, and there we go, turn red on. And what that will do now is every time it reads turn red on, it will go up to this function here and it will turn the red on. So nice and simple. If you notice here, we've got one here that's actually a predefined function within the Arduino language. So delay is already a function. Now what's interesting about the delay function is that you see between the curly brackets for turn red on, we have no value. In delay, you write a value, an integer value. And that integer value refers to a number of milliseconds. So what we're doing here is we're having one function, which is called delay. And when you enter the value here, delay takes that value, and as the function would suggest for delay, it uses that value to pause, if you like, the functionality of the product for 2000 milliseconds or 2 seconds. So here's delay again, but it's only for half a second, 500 milliseconds. So we can keep reusing this delay function, and we don't have to write all the complicated code that's behind the delay function, which actually causes the pause in the program. So now what we've done is we've created our own function which is turn red on, and then here we see we've got one which is amber. So what we could do is we could actually recreate this code, and just for speed I'm going to just cut and paste it, and instead of it being red, it's now amber on. And then the digital write here is actually amber. So this turn amber on function can replace this piece of code here. And we can then go through and we can create codes for turn red on, turn amber on, turn red off, turn amber off, and so on. So as we go through this particular code, now what's interesting here is actually these functions aren't particularly efficient, because at the moment we're just changing one line of code. So digital right, red low, which is turn red off. We're then making that into a function, and then we're having to call the function, and then it has to read the function, and then it goes back to where it was in the loop. So really that's not a particularly efficient function because it's only one line of code. But what we can do, which we're going to do right now, is what we've created here in loop is actually, if you like, a long list of different commands for switching on and switching off lights, and we're calling a couple of functions. What we can actually create, and we're going to do that now, is another function, and we're going to call this one sequence1. And it's always useful if you use the double slash. That is a comment that you're adding in, so now we can say what sequence1 is, and the computer won't actually try to interpret that. So what is sequence1? Well, sequence1 is a sequence of traffic lights. And what we're going to put into this code is actually currently everything that we've got within our loop. So we're going to take that from there and we're going to put it here. And then at the end of it, what we have to do is we have to put in the curly brackets to close this particular function. So we've now got a function called sequence1. So now within loop, I can actually just write in, making sure we get the right case sensitivity, sequence1, and that is all that we have to write within the loop function. So now we've got sequence1, and when it calls sequence1, it actually goes up to this function here, and it follows the instructions that are within that function. So why would we do that? Well, the great thing is now is that I could have another sequence which could be called sequence2, and I could call either sequence1 or sequence2 in my loop. So I might have a switch that if the switch is high, I want it to run sequence1, and if the switch is low, I want to run sequence2. So within the loop, I can just put in an if statement, and then I can call two different sequences of my traffic lights. And that way, what you're effectively doing is getting rid of the need to keep rewriting all the code that's within sequence1. You just use the single line statement. And that's where functions actually become a lot more efficient as a coding exercise. And also it makes a lot more clarity because you can give these sequences a specific name, and then you can actually create the code. Once this code works and you've debugged it to make sure that it does as it's meant to do, and it switches them on and off in the sequence that you want it to do, you know every time that you write sequence1, it will regenerate that code, and it will call that function and therefore operate exactly as you expect, and you won't have to keep debugging it. So that's a really basic explanation of functions. And what we will do in the next one is that we will actually have a look at how we can have a function where, a bit like delay, you're putting in some information into the function, and then in a fourth part to our traffic light sequence, we're actually going to create a function where there's an output. So instead of it being a void, it will actually return a value into the system, and then the system will use that value. So I hope you enjoy your coding.